The Earth is heating up. This is due to greenhouse gases, mainly carbon dioxide, trapping heat from the sun. Like a blanket, these gases are becoming thicker, leading to rising temperatures. This phenomenon, known as climate change, poses a significant threat to our planet. We see more extreme weather events like heat waves, droughts, and floods. Glaciers are melting and sea levels are rising. The primary culprit behind this warming is the burning of fossil fuels. Coal, oil, and natural gas release vast amounts of carbon dioxide into the atmosphere. This disrupts the natural carbon cycle, leading to an excess of greenhouse gases. The need to reduce our reliance on fossil fuels is more critical than ever. While transitioning to cleaner energy sources is crucial, we also need innovative solutions to address existing emissions. This is where carbon capture technology comes in. Imagine being able to catch carbon dioxide before it escapes into the atmosphere, like capturing fireflies in a jar. This is not just a dream but a reality that scientists and engineers are working tirelessly to achieve. The concept is simple yet revolutionary. That's essentially what carbon capture technology aims to do. It's a groundbreaking approach to mitigate the effects of climate change by preventing harmful emissions from entering our atmosphere. It acts like a giant filter, trapping carbon dioxide from various sources. These sources can range from industrial plants to power stations, and even directly from the air we breathe. This trapped carbon dioxide can then be stored safely or even repurposed for other uses. For instance, it can be injected into underground storage sites or used in the production of materials like concrete and plastics. There are three main types of carbon capture: pre-combustion, post-combustion, and direct air capture. Each method has its own unique process and application. Each method targets carbon dioxide at different stages, offering a range of solutions for various industries. This versatility makes carbon capture a valuable tool in our environmental toolkit. Understanding these different approaches is key to grasping the potential of carbon capture in the fight against climate change. It's not just about technology, it's about creating a sustainable future. Think of it like this. Pre-combustion capture is like stopping someone from littering before they even do it. It's a proactive approach to prevent emissions at the source. Post-combustion capture is like cleaning up the litter after it's been thrown on the ground. This method captures emissions after they have been produced, ensuring they don't reach the atmosphere. And direct air capture is like using a giant vacuum cleaner to suck up the litter that's already spread around. This method captures carbon dioxide directly from the air, making it a versatile solution for reducing atmospheric CO₂ levels. Imagine you have a big plate of char siu rice. Now imagine being able to separate the char siu, rice and sauce before you even take a bite. That's kind of what pre-combustion capture does with fossil fuels. This method captures carbon dioxide before it's even produced during burning. Pre-combustion capture is typically used in industries like power plants and manufacturing facilities. It involves converting fossil fuels into a mixture of hydrogen gas and carbon dioxide. This mixture then undergoes a separation process, isolating the carbon dioxide and leaving behind hydrogen, which burns cleanly. This method is particularly effective because the carbon dioxide concentration is much higher before combustion, making it easier to capture. It's like separating ingredients in a recipe before they're all mixed up and cooked. Post-combustion capture, on the other hand, is like using a sieve to separate the noodles from the soup after you've finished cooking your laksa. This method captures carbon dioxide from the flue gases released after fossil fuels are burned. This technology is often retrofitted onto existing power plants and industrial facilities. It involves using solvents or solid materials to absorb carbon dioxide from the flue gas stream. The captured carbon dioxide is then released from the solvent or material, leaving behind a purified gas stream that can be safely released into the atmosphere. While not as efficient as pre-combustion capture, post-combustion capture is more versatile. It can be applied to a wider range of industries and facilities, even those that aren't designed for carbon capture. Section 5. Straight from the air. Direct air capture. Imagine using a giant air purifier to suck up carbon dioxide directly from the atmosphere. This isn't science fiction, it's a real technology called direct air capture. That's essentially what direct air capture does, albeit on a much larger scale. It involves sophisticated machinery and advanced engineering to make it feasible. This technology uses large fans to draw in air and pass it through filters or chemical absorbers that trap carbon dioxide. The captured CO₂ can then be stored or repurposed. Direct air capture has the advantage of being location independent. This means it can be set up in remote areas, far from urban centers or emission sources. Unlike pre-combustion and post-combustion capture, which require proximity to emission sources, direct air capture can be deployed virtually anywhere. This flexibility is a significant benefit. This makes it a promising solution for removing carbon dioxide from the atmosphere in a more distributed manner. It can be part of a global strategy to combat climate change. While still in its early stages of development, direct air capture has garnered significant interest and investment. Researchers and companies are working hard to improve its efficiency and reduce costs. Companies like Climeworks in Switzerland and Carbon Engineering in Canada are at the forefront of this technology, developing and deploying large-scale direct air capture plants. These pioneers are paving the way for a cleaner, more sustainable future. Section 6. Locking it away, CO₂ Storage and Utilization. Now that we've captured all this CO₂, what do we do with it? The captured CO₂ can be either stored safely away from the atmosphere or utilized in various industries. The most common storage method is geological storage, where CO₂ is injected deep underground into porous rock formations. These formations act like giant sponges, trapping the CO₂ for centuries. Think of it like hiding your Angbaus in your secret hiding spot, but on a much larger scale. Alternatively, the captured CO₂ can be utilized in various industrial processes. For example, CO₂ can be used to enhance oil recovery, create synthetic fuels, or manufacture building materials. This utilization pathway helps offset the costs of carbon capture while also reducing emissions in other sectors. Check 1, check 2, check. Section 7. The hurdles ahead, cost and scaling up. While carbon capture technology holds immense promise, it also faces significant challenges. One of the biggest hurdles is cost. Currently, carbon capture is an expensive endeavor, requiring significant upfront investment and ongoing operational costs. Scaling up carbon capture to a level that can make a meaningful impact on climate change is another major challenge. The technology is still relatively nascent, and deploying it on a large scale will require overcoming technological, logistical, and financial barriers. However, just like how the price of handphones dropped as technology advanced, the cost of carbon capture is expected to decrease as the technology matures and economies of scale kick in. Increased government support and private sector investment will be crucial in driving down costs and accelerating deployment. Section 8. A powerful partnership: carbon capture and renewables. It's important to remember that carbon capture is not a standalone solution to climate change. It's not about continuing to burn fossil fuels with reckless abandon. Instead, carbon capture should be viewed as one of the tools in our climate action toolkit, working in tandem with other solutions like renewable energy. Think of it as a football team. Carbon capture is like the goalkeeper, preventing emissions from scoring. But we also need a strong defense, renewable energy, energy efficiency, and a strategic offense, sustainable transportation, responsible consumption, to win the game against climate change. Integrating carbon capture with renewable energy sources like solar and wind power can create a powerful synergy. For example, excess renewable energy can be used to power direct air capture plants, creating a closed-loop system that removes CO₂ from the atmosphere using clean energy. Section 9. A multi-pronged approach for a cooler tomorrow. Climate change is a complex problem that demands a multifaceted approach. It's not just about reducing emissions, it's about transforming our entire way of life. From the way we produce energy to how we consume resources, every aspect needs to be rethought and re-engineered. Carbon capture technology, while not a silver bullet, offers a valuable tool in our fight against rising temperatures. This technology can capture up to 90% of CO₂ emissions produced from the use of fossil fuels in electricity generation and industrial processes, preventing CO₂ from entering the atmosphere. From capturing CO₂ before and after combustion to pulling it directly from the air, these technologies offer a range of solutions for various sectors. Direct air capture, for instance, can be particularly useful in sectors where emissions are hard to eliminate. However, it's crucial to remember that carbon capture is most effective when deployed alongside other climate actions. Transitioning to renewable energy, improving energy efficiency, and reducing overall consumption are all critical components of a comprehensive climate strategy. Adopting sustainable practices remains paramount. This includes everything from sustainable agriculture to eco-friendly habits at home. Every small action contributes to a larger impact. It's like going for a jog. Carbon capture is like wearing ankle weights, making your run more effective, but you still need to put in the effort to see results. The same goes for our climate efforts. Carbon capture enhances our actions, but it doesn't replace the need for them. By investing in research and development, we can continue to improve these technologies, making them more efficient and cost-effective. Supporting policies that incentivize carbon capture is also crucial. Governments play a key role in creating a favorable environment for these technologies to thrive. Fostering collaboration between governments, industries, and communities is essential. By working together, we can unlock the full potential of this technology and ensure it is integrated into a broader climate strategy. Let's embrace a future where carbon capture works in harmony with other solutions, paving the way for a cleaner, cooler, and more sustainable planet for generations to come. Together, we can make a difference and create a legacy of environmental stewardship.